Right, so I already recorded this once and the file corrupted. So we're actually gonna do this. I did it in 9 minutes last time, so we're gonna do it 6 minutes this time because I have other homework to do. I'm gonna be for real. All right, start that timer, share the screen. All right, slideshow. All right, welcome to my presentation on the aircraft incident with Southwest Flight 812. Um, what happened April 1st, 2011, on a standard flight from Phoenix, Arizona to Sacramento, California. The aircraft in question was a standard issue Boeing 737-300. It was an older aircraft with 39,000 flight cycles. Down here in the corner, I have a note. Flight cycles are defined as pressurized and depressurized events. So when a plane goes up, it becomes pressurized. When it comes down, it becomes depressurized because you pressurize the cabin for air quality, and so people don't suffocate. And so when you come back down, there's no need for that. So the cabin depressurizes. So stress on the joints happens when the plane is pressurized because obviously pressure expands and there's pressure on the inside and outside. And when it comes down, it goes, all right. The outcome of this was a successful emergency landing at Yuma Marine Corps Air Station in Arizona with no fatalities, which is a gift in and of itself, especially with most flight incidents resulting in multiple fatalities, if not all fatalities. The critical moment in this case is the fuselage rupture. As you can see, the arrow pointing to that little strip right there. At 34,000 feet, a loud bang happened as a 5 foot by 1 foot section of the fuselage skin ruptured and tore, causing a rapid decompression of the cabin. Fortunately, the crew, the pilot and his first officer, were highly trained and skilled in for moments like this, and they began a rapid descent from 34,000 to 11,000 feet in minutes. I don't know how many of you have been on planes before, but this is an extreme amount of feet to descend, and it is highly impressive. Despite sustaining a laceration to the head and bleeding, one of the flight attendants with their co-workers were able to move through the cabin, instructing passengers and ensuring oxygen masks were properly fastened, and everybody had theirs on. Excuse me. As mentioned before, the incident outcome for this was a total of zero fatalities, which is a miracle, as most incidents like this result in several either severe injuries, fatalities, or everyone on board unfortunately perishes. Um, all 117 passengers and 5 crew members were evacuated safely on the ground when they landed in Yuma. This whole situation is a testament to proper training and the structural integrity of the remaining airframe of this specific 737. Now, the NTSB investigation led itself to um, a conclusion that the fuselage skin panel had widespread metal fatigue, specifically at a lap joint, which is an overlapping seam in the fuselage from multiple small fatigue cracks that had linked together. Now, at the time, um, the standard was walk around the plane for maintenance, check the outside, check the inside, but all of these cracks were on the inner side of the skin panel. And because the inspections were not as in-depth, they missed them for several inspections, and that is why these cracks were allowed to spread until they ultimately connected and caused the rupture of the skin. This is just a further in-depth look at the frame here. This is what the lap joint would look like. Um, Furthermore, this aircraft was extremely old, as mentioned before, 39,000 cycles, where the failure occurred at a lap joint, as illustrated here. And these are held together by rivets. So you would imagine that a bunch of holes with a bunch of stress fractures that link up would cause a pretty catastrophic event. As mentioned before, these were hidden from view. So this is where the industry-wide impact comes into play. All Boeing 737s were grounded by Southwest Airlines. 80 of the similar 737-300 aircraft for immediate inspection, which revealed similar but less severe fatigue cracks on many of these aircraft. Now, what happens here is the flight authority basically says we need to inspect all 737s, no matter if they're 300, 400, or 500 models, for similar things, and they um, added the use of advanced eddy current inspections, and these were used to detect subsurface cracks. The lessons learned from all of this and the lasting changes are as planes get older, we need more in-depth inspections. We cannot just do surface level visual inspections. It forced the industry to adopt more advanced and non-destructive inspection and techniques. So instead of going in a very invasive way, which could compromise the structural integrity of the plane, to find new ways to test for these stress fractures and overall like health of the rivets and the joints of the plane. A lot of data was taken from this, mainly from the rivets and the overall area of fatigue, but also training for crews and flight attendants because they did their job in a perfect, in like almost to a perfectious moment, like standard under high pressure. Literally plummeting out of the sky with a depressurized cabin. They held their cool and took care of everybody. Everybody survived with two major sustained injuries. In conclusion, this was a near disaster averted by a well-trained crew and a well-designed airframe. Despite all the things that went wrong, the plane held together and the crew was able to get everybody on the ground. And this is just a quick video to illustrate the close-up as they were doing the investigation. That is a fairly sizable part of the plane. But thank you for watching. Sadly, the first one didn't go through. But anyways, y'all have a good one.